Hello, everyone. Welcome to another Levine lunchtime webinar. So glad you could join us. I certainly apologize if there's any background noise. I had to go to Plan B and come into my local LA Fitness to use their Wi-Fi connection. Our internet at home went out, so hopefully this works out. Today we have a very special guest. Eric Hubbard has been with ELSPEC for about 3 years. He is in charge of their metering division, and Eric certainly knows his way around meters. A couple housekeeping items. Your phones are muted. This is a webcast, but we would love to hear from you, and we would love for you to participate and ask questions. There's a button the lower left-hand corner of your screen where you can press it and ask a question. And if you want to, go ahead and test that button. Go ahead and press it and just type in something you'd like to learn today about portable meters in general. So again, thank you so much for attending. And without further ado, let's see what Eric Hubbard has for us in the cupboard.
Hello, everybody. Thank you for attending. Are you controlling the slides, or am I going to be controlling the slides?
So if you can't share your screen, I'm going to control the slides, and I'm on slide 1, which shows the title slide, and it's the impacts of electrical reliability. And just prompt me when you'd like me to change the slide.
All righty, sounds good. So my name is Eric Hubbard. I am the product manager at ELSPEC, and I work on the utility side of meters and software. And I was invited to come speak today and go over some meter work and some software. So let's get started, and we'll go ahead and start on the first slide.
Great. The slide says overview.
Okay. That's not the one I'm seeing, but okay. So what we're going to go over today is portable meters. We're going to go over some current probes and then some data retrieval and usage. Okay, next slide.
Okay, it's a picture of the Pure meter.
So we have a total of 3 portable meters. The first one we're going to go over is a single phase Pure. It's designed for inline series voltage and current measurements. There's 2 different models. One will measure voltage only, the other one measures voltage and current. It's perfect for single device measurements, and like its older sibling, the 3-phase Pure, it does 256 samples per cycle. Next slide, please. The next slide just kind of shows an overview diagram of what the Pure looks like. So the very top is where you would plug in the field your device, such as a TV, a machine that has under 10 amps, 12 amps of current. You plug it into the top, then the bottom you would plug into the wall, and you would end up getting, you just leave it there, and it would record data continuously for you, 256 samples per cycle. And the storage on the side has an SD card and a USB socket. And that's for data retrieval. Next slide, please. The specifications on it, it's a very simple device. This was just designed primarily to help out with single items on industrial lines, for manufacturing, for hospitals, to give them a quick, brief, and dirty overview of the system. It's good for, like I said, 256 samples per cycle, continuous waveform, up to 240 volts measurement, only one channel, and It also does 5 volts DC over USB. So if you have something else that you need to power with the USB, you can do it as well. Next slide. Operating temperature on it is -20 to 60 degrees C. It has also got a IP40 rating for the intrusion, and it's very light. I have one, and it's right around a little bit less than a pound. Same, from kilograms to pounds. Size-wise, it's about the length of a decent book, and just a couple inches wide. Next slide, please. So next we have the 3-phase Pure, 256 samples per cycle. Its design rationale was everybody needs one that they can just carry with them anywhere. So we make one really small, we make one portable, and give the end user the ability to have it with them at all times. As you can see, you've got the 4 B and C connections for current probes, and you've also got the 5 banana plugs for alligator clip, banana plug connections. Those are for your voltage. You also see right below that there's some white dots. Those are colored LEDs. There is no setup required whatsoever with this device. You just plug it in and walk away from it. You don't have to do any event triggering, any type of triggers like that. You don't have to do any setup. The LEDs will tell you if you're phased correctly. So if you have a voltage or a current phase swapped, then you'll get a yellow or a red light on the LED showing up that you do have an incorrect rotation. It is also, if you have the extension module, it is compatible with the Android or Apple app for waveform phasor viewing, voltage viewing, just to get a quick view of everything on the fly. Next screen, please. This one does have some accessories. There is a battery extension module, and the extension module is what gives it the ability to have a Wi-Fi module or an Ethernet port. The Wi-Fi module is going to be like just a standard USB plug-in module. You can also use cellular for the same hub. So it's whichever one you want to use with. The SD card, you can't hot swap it, so you can just pop it in, pop it out. If you're running around checking your meters and you're just bringing your data back with you, you can just plug and play the new SD cards. Next screen, please. Here is the next screen. This is we just came out with this, and it's available probably in about a month, but it allows it to power off of the line. So you see one connected in the field here. This gives it a 305 volt AC upper limit by itself, so you can line power it without having to worry about hunting for a wall outlet anywhere. You can power it directly off the line you're measuring. And then there is also a transformer that will allow you to line power off 600 volts. As you can see in the picture, you can see the LEDs are all lit up and they're all green. So that indicates that this has been installed and is phased correctly. Next screen, please. Now on this screen, we have some basic specifications and the dimensions of it. This is shown without the extension module. If you look at the bottom right corner where it has the power connection, that is where the extension module just slides in. So that bottom piece removes, the extension module moves in to that connection, and that gives you all the additional accessories that are needed to really to go out and leave it hooked up for 8 hours with no power supply. So it kind of covers a wide range of scenarios. Next slide, please. These are just a couple of screenshots of the side-by-side comparison of the specifications between the three-phase and the single-phase meter. I already went over the single-phase. They're good for 40 to 70 hertz line frequency. Both of them are 256 samples per cycle, 50 or 60 hertz. They're both IEC 6100 Class A power quality meters. And the three-phase one has the ability for 4-channel current probes and then the 5-channel voltage. You can measure up to 690 volts AC direct. Typical installation is going to be on the secondary of your transformers, where you're going to be in your 277, 480, and below range. But there is the option to go up if you need to, or if you find yourself in a situation a little bit above. Next slide, please. For communication purposes, there is, with the extension module, there is a LAN connection. So with a DHCP server, your home Wi-Fi, you can plug and play, and it will assign it an IP address, and then you can browse to it to remove your data, FTP, however, and we'll go into that a little bit later on. It does have our patented PQ zip files, so it allows a compression so where you can record this waveform data continuously and not end up dealing with massive data files. The software will do the decompression for you. The power supply, 240 volts AC until the new one comes out, and it goes upwards to a little bit over 300. Okay, next slide, please. And it does have, with the extension module, the other part that I forgot to mention is that you can also sync a GPS up to it. Operating temperature as well is -20 to 70 degrees. Same rating, IP40. This does have also a optional NEMA enclosure, which does make it watertight. If you're going to be outdoors in a potentially damp or wet scenario, you can install it in a NEMA enclosure. Next slide, please. And here is the audience poll. What voltage levels do you typically monitor with portable meters?
For whatever reason, our poll system is not functioning correctly. So just go ahead to the next slide.
Okay. And the next slide brings us to our G4500 portable meter. This is a very heavy-duty, industrial-style power quality meter. It has on one side, so we'll start on the left-hand side, it's got a Wi-Fi antenna, which allows you to connect to and browse the web server via Wi-Fi. It has some input-output modules, 4 digital inputs, has 2 Ethernet ports and a WAN port. It also supports power over Ethernet. On the back side, you have 4 voltage inputs. You can also do DC voltage in, and you have up to 5 current inputs, one of which can be used for DC current with the DC voltage. Excuse me, and the power supply. Next screen, please. So what makes the 4500 very usable is it does have Wi-Fi for easy data retrieval. So it allows you to pull up, sync your computer to the Wi-Fi signal, and download some data. It has a built-in web server for easy programming setup, and it supports a wide range of current probes. In addition to that, it also supports being set up via the Android and the Apple app. So a lot of people, they'll get a cheap, like a Kindle Fire or a cheap Apple tablet, install the app, and it goes with it, and it handles all the setups and the data checking for the meter that way. Next slide, please. Here's another picture of it. This one doesn't have any current probes connected, but you can see the connections for the current probes. And this one is also going to be compatible with the line powering 600 volt transformer. That way, that will allow it to do away with the 120 volt plug over there. It'll just plug into the transformer and allow you to use this very rugged instrument outside in transformers up to 600 volts. So you don't have to worry about extension cords. You don't have to worry about, having the doors even remotely propped open anymore. It just plugs and plays now. Well, when the transformer gets here at the end of this month. Next screen, please. Unlike the Pure, the sampling rate on the 4500 goes up to 1024 cycles per 1024 samples per cycle. The current sampling rate is 256 samples per cycle, and the internal memory is right around 32 gigabytes. So it gives you quite a bit of storage for the size and for the time that you're going to be recording. You can go several weeks to several months. Operational temperature 0 C to 50 C, which is basically 32 to 122 Fahrenheit. Next screen, please. This is just included for reference. It does have power over Ethernet. You can also power it off 48 volts DC. The battery backup is good for 2 hours in it. It does sync to a GPS, and you can also route it to an SMTP server if you have it set up on your network. Here's a list of all the measurement standards that it meets and the communication ports that come with it. Next slide, please. Okay. As far as the communication standards, as far as these standards go that you see, most of those are all related to power quality. In addition to the 519, which is the new harmonics protocol, it does meet all the standards to correctly measure that, and the software will generate an actual PDF report that goes over the standard and breaks it up into your different sections. Next slide, please. So those are basically the specs and everything of the 3 meters. And as I mentioned, the Pure does not require any setup. So we're going to go over setting up for the 4500 for an on-site installation. The setup is actually very simple. You plug it in to power it up. You turn it on. You connect to it via Wi-Fi or Ethernet, however you wish to connect. You hook the voltage and the current probes up onto the system you're measuring, and then you go to the website interface and log in to begin setting up your parameters, and then you start recording. Next screen, please. So they're basically plug in, connect, and wire. That is the general overview of how the 4500 works. You're connecting the power supplies. You're connecting the network cable. You're connecting to the Wi-Fi. You're connecting to LAN 1. And then you attach your voltage cords. You connect your current clamps to your current probes. And then you verify your connection with the presence indication LED. That's an LED that's on the front panel, and it shows you if everything's connected and good. Next screen, please. Now, once you're connected, one of the big questions is, how do I know which IP address to go to? There is a ELSPEC device search utility, and you run it, and in the top screenshot, you see an IP address, the description, the subnet mask, and some options of how to connect. Now, that's very useful if you have multiple on the same network, because it gives you the ability to find which media you're looking for, so you don't get confused when you're logging in. So in this case, you would browse to the DOP website, and then you would log in as an administrator to the website's internal web server with the admin password 12345. That gives you full control to adjust, change, and manipulate the settings. Next screen, please. Once you connect it, to help you with your data recognition at a later date, you can change the site name and the operator, so you can put in where you're located, and also the person who's using it. So if you send out a bunch of people with a bunch of meters, you know who's responsible for setting up that particular meter. And it kind of helps keep track of who did what during the test and installation. Next slide, please. One of the other things that you want to configure is you want to configure your voltage, primary and secondary. So if you're concerned with what you're measuring, you're not trying to do a conversion from a PT to medium voltage or anything, you would set your ratios up to be a 400 to 400 or a 1-to-1 ratio. So if you're measuring 120, you're going to see 120 in the data. You set it up 400 to 1, and you're going to see a multiple of 400. Polarity is there for the voltage as well, where you can change it if need be, in case a PT is backwards. And then it gives you the nominal frequency and the nominal line-to-line voltage that you can set as your nominals. In this case, it's showing 50, but we would set it to 60 here in the States. Next slide, please. The other connections that you want to worry about is your current transformers. So if you are on the secondary of the CT, you would put in the correct ratio for your transformer. So if you're on a 500 to 5, you would put 500 to 5 in your ratio. And then you would also set your nominal current. And then also you see where it says current polarity. If somebody has hooked up the current probe backwards, you can swap the direction in the software, which is always handy if they had to do, power the system down to do the hookups, and you don't want to power the system down again. You can just swap the polarity in the software. If you are measuring actual line currents, say up to 3,000 amps or so, then you're going to do the same thing on your ratio of the current, and it's going to end up being a 1-to-1 ratio, and it will let the current probes at that point take over. Next slide, please. There's a summary screen that you will see when you log in. This is a great way to get a brief overview glimpse of the system. It gives you your frequency, your three-phase current average, your three-phase voltage average, your total power factor, your phase order, lets you know if there's any time synchronization, and lets you know if your DSP is on and synchronized. The time synchronization as shown in the picture says self, so that means it's going to be synchronized off of whatever you program the meter to be. If there is an SMTP server, it'll say SMTP, and then it'll give you a signal strength. Same with the GPS. So if you have a GPS synced up to it, it'll say GPS good. Next slide, please. Monitoring and your phasor screen. This is an excellent way at a glance to look at your three-phase voltage and current. Make sure that everything you're seeing makes sense. There has been some changes with the internet browsers over the years where ActiveX sometimes does not show up. So in that case, you're just going to be looking at the phase angles and drawing them out if you have to on your own. But it's very important to make sure that your system is phased correctly. If not, you'll end up with faulty readings. Some of that can be fixed inside of Sapphire, some of it can't. So it's always best to make sure that you get the data right the first time when you bring it in, and that you're bringing in all the data that you can bring in that you need to see. Next slide, please. And then if you just want to look straight at RMS values, min-max values, there's another monitoring screen that shows your voltage and current. And it's always good to look at these and make sure that everything makes sense here as well. You don't want to see like 100 amps, 100 amps, and 1,000 amps, because that means that you've probably got a setting on your current probes, or you've got a configuration setting incorrect in the software. So this is one last brief check to make sure that your data and your information makes sense. Next slide, please. And this slide shows an example of something that went wrong in the hookup. So you see your power. You've got 61 kilowatts, 26 kilowatts, -0 kilowatts. So phase 3 is backwards in this case. So they had to go in and fix it to change the CT ratios to make sure that it came out and made sense. So this is one of those instances where you want to make sure that everything is correct. So, always go over when you do a hookup. Even if you don't have a computer, everybody's got a phone with them. Make sure you've got that app on there and you log in and all the information makes sense. Okay, next slide, please. And then finally, one of the final things that you want to do before you leave the site is you want to go to the PQ zip recording, and you want to make sure that it is indeed enabled and turned on. You will see an indication that the PQ zip recording is on. You've got to make sure it is. If not, then it's just going to sit there and not record anything. So make sure that you do start the recording. Next slide. So for reference, we've got a couple of different types of CTs we're going to go over as well. The first one is the 1 to 6 amp mini clamp. What this clamp's primary purpose is for secondary metering of current transformers. So this is the probe that's going to go onto the secondary of your 500 to 5s to where you have 5 amps max current. This is going to give you a little bit better resolution because the maximum is 6 amps. It's got a smaller window, so that way you get better seating on the current and increases your overall accuracy as opposed to trying to measure 5 amps with a 100 amp Rogowski coil or something. Next slide, please. And then we have the flexible current clamps, the Rogowski coils. This one is a 3000 amp flex probe. This goes around your actual line current. A couple of things to remember on this. You always want to make sure that you're under the voltage range. So this is good to up to 1,000 volts. So you don't want to go in and put this around, 3.3 or something setting. So you want to keep the voltage and the current range about the same. The 4500 is set up to auto detect most of the probes that come with it, so you don't have to worry too much about your settings. Next screen, please. This was the second poll, but I believe since polls are not working, we're going to go on to the next one. But I do, this is something just to kind of think about in the future and going forward. Something I'm always looking for feedback for is, what is your preferred method of data retrieval? Do you always just like to hook it up and have enterprise style software bring that data in? Wi-Fi to quick connect, USB cards for hot swappable downloads. So there's a couple of interesting ways out there to do data retrieval. Next slide, please. And you can go ahead and go to the next slide right after this one too. So what we're going to go into now is the data retrieval on these devices. So for the Pure, we have PQ SCADA Enterprise data retrieval, network or FTP, SD card to PC, USB card to PC. The enterprise software will always download meters on the network. So if you have Sapphire running and you have meters on your network, Sapphire is always going to be downloading the data in the background. So you don't ever have to worry about anything once everything's hooked up and connected correctly. You connect the Pure to your network via an Ethernet cable. Your network will then assign an IP address to the Pure, and then you set up Sapphire to monitor and retrieve data. Next slide, please. And here is a screenshot of Sapphire. So once you have the IP address, that's all you need to have to set it up in here. You just go to your Systems tab, you add the component, you put in the IP address, and then it automatically has your meter in its database organizational tree. Next slide, please. So if you're not going to use the enterprise software, you just like to just go out and bring the data or whatever back in, the next best way is, doing an FTP server. The same thing, you can have it on a network, you can direct connect to it with an Ethernet cable. So you would just open your FTP client, you enter the IP address of the Pure, and you find that IP address with that ELSPEC device search tool I mentioned earlier. You put in the username and password, download data from the PQZip folder. Next slide, please. This is a example of FileZilla, which is an FTP client. As you can see in the upper left-hand corner where the arrows are pointing, you've got your IP address, you've got the username, and you've got the password. And then you hit Quick Connect, and it opens up your file service. And then you browse to the PQZ data folder. And in this case, you see inside of it there is a file, has a very long file name that it ends in PQZip. This is the file that you want to download to your computer, and you'd store that in a location where you can come back and find it at any time, because that's going to have all the data you need to get into Sapphire. Next slide, please. And the next methods of data retrieval from the Pure is there is an SD card inside of it. You can just pop the SD card out. If your computer has a SD card reader, you plug into it. If not, you put it into a card reader, download the files to your computer, and put them into Sapphire. Next slide, please. And the final method of data retrieval is USB cable. You would just plug the USB cable into the Pure, into your laptop, browse to the same file folder you do with an FTP client, and then retrieve the data and pull it back to your laptop. Next slide, please. So the 4500, being a little bit older version, only has the two methods of data retrieval, either using the enterprise software or browsing and using an FTP server. Next slide, please. With enterprise software, it works the same as the Pure. You hook the 45 up to the network via an Ethernet cable. You launch Sapphire, and then you assign the IP address and you retrieve data. Next slide, please. So as you can see here, the same thing would happen. You would, once you put the IP address in and attach the component to your local server, it then shows up on your server tree, and the data will start automatically downloading. And when it downloads, it automatically processes as well. Next slide. So if you do not want to do that, then the next obvious way is going to be the FTP server. Same thing, you connect to it, direct connect with an Ethernet cable or the Wi-Fi, open the FTP client, and download the data. Next screen, please. The difference between the Pure and the 4500 is the username and passwords are different for both of them. The 4500 and then a couple of our fixed meters have the same, and then the Pure and another fixed have the same based on the generations they were built. But they also, you do have the ability in the 4500 to change that username and password. Browse to your folder, you download your data back to your local hard drive, and then you import it to software. Next slide, please. So what we're going to cover here in the next few minutes is the data manipulation. So you've done your research, you've had your devices in the field, so you bring it back in. Now what do you do with the data? What can you do with it? How do you look at it? How do you bring it in and start off on Sapphire? Okay, next screen, please. So there are three options when you bring in data into Sapphire from the investigation tab. If you look at the screen, the very top, you've got an overview, a power quality, an investigation, an energy, and a systems tab. All data analysis, data acquisition begins in the investigation tab. So you're investigating your power quality environment. You can drag and drop the PQZip files directly into a folder. You can drag those into a folder and attach them to a component, or you can just click the Start a New Investigation button, which is the preferred way and the way most people will do it. Next screen, please. So when you click this new investigation, the very first thing that you want to do is you want to give it a discrete name so you remember what you're doing. Lumber mill number 1, substation 2, whatever that meter is, be as specific as possible when you're doing this. So when it comes to it later, you can get it going pretty good. Component is a component that you have attached to your server. FTP folder and file folder opens up browser windows and allows you to browse to locations either to the FTP client in the meter or to a folder on your PC. Next slide, please. In this case, we're going and we're grabbing a component. So I am basically taking the software and saying, hey, go to this meter's database on this PC, and this is where we're getting the data from. So you select what component you're going with. Next slide, please. And then you come to the section where you define what timestamp you want to look at. If you are hooked up on an internet connection, with this, and you have an actual live feed to it, you can do a live stream of the voltage, the current, the phasors, so you can see in real time what your voltage and current look like on the site. You can select last month, last 30 days, 7 days, hours, or you can do a custom where you do from a set date and time to another set date and time. And all that does is tells the database, I want data in this section to look at right now. Next screen, please. Once you select your time interval, then you have to select what type of graph or what type of processing you're going to be doing. You can do trend data, you can do spectrum, you can do events, you can do templates, you can do scatter graphs. There is a whole multitude of options at this point. We're going to go with the trend though, so we're going to start our trend graph. So next screen, please. Now, once you select where you're going, you come to a section where you define exactly what you're looking for. In this case, under parameter, I typed in RMS. So that pulls up some RMS functions. In this case, I'm just pulling up three-phase voltage, three-phase current, cycle by cycle, and then the average value. Next slide, please. And once I hit finish or enter, it then gives the RMS graph. So I have voltage and current graph now in RMS values. From this screen, I can add more parameters to these graphs. I can add more graphs to this investigation. I could zoom in, I can zoom out. I can run a new query on a larger time base. I can export this data to a CSV file. I can create a Word document. I can share my investigation. Multiple things can happen once you get the data to this point. Next screen, please. So what we are going to do is the voltage and current's great. It tells us a little bit about this, but I really want to look at some more values as well. So what I'm going to do is I'm going to go to the Actions tab, and I'm going to add a new chart. So I'm now going to have the voltage and the current graphs, and now I'm going to add more graphs to this section of the investigation. Next slide, please. So what I did was I went and added some power and some frequency. So now I have multiple graphs on here. You can scroll up and down on the sidebar, and that brings you up and down to look at all the values you have. In the upper right-hand corner, there's a little red box around it. That allows me to save the investigation if I want to come back to it later, export it to Word, or send it to an email so I can email the investigation to somebody else. On the left-hand side, you see all the different types of graphs that are on here. If I want to narrow it down to maybe just a couple, there's a little black box I can check or uncheck, so I can manipulate all of this without having to go back in and out and change any more types of parameters or anything. If I want to look at them all at the same time, next slide, please. I can export them all to the clipboard and then paste that into a Word document or a photo viewer, and then I can see all my graphs on the same screen. So it kind of manipulates the size of the data, screenshot and everything, so you can then see it. Okay, next slide, please. Now, if this is something that you do a lot, you're always processing data. Nobody wants to go in and add all these graphs time after time after time. So there is the ability in here as well to do what's called create a template. So I have in this particular file, I have voltage, current, active, reactive, apparent power, and frequency. And that's what I want to see, say, every time that I do an investigation. That's what I want to always see. So I can save this as a template. Next screen, please. And so I can go in here and give this a unique name. And so in this case, I'm going to call it training L3. When I get back to want to bring up sorry, go to the next slide as well, please. Saving this. So when I go in here and pull up the trend data again, you can now see that I have the option at the very bottom for template. So I select that template, select the name that I just input into it. Next slide, please. And then it pulls up and pre-populates it based on the previous template. So every time I want to do an investigation with these parameters, I just run the template over and over and over again on every file that comes through. So I don't have to spend any additional time adding all these graphs. I can just run the template and it pulls up and it gives me the same data. Okay. Next slide, please. And then the final section we're going to talk about today is power quality events. So with the Pure and the 4500 to a degree, there are events that that automatically are defined, sags, swells, etc. But you can also redefine these in Sapphire to create whatever you're looking for. So if you're looking for a 75% sag, you can build that in Sapphire. Okay, next slide, please. So on the power quality tab, remember the tabs I was mentioning at the top, when you set in a time range, it gives you a list of all the power quality events that happened during that time period. As you can see here, I've got the sags or dips opened up. And this gives you a list of all the dips or sags that occurred during the viewable time frame. All you have to do to begin an investigation from this point is just click on that particular event. Okay, next slide, please. And then just like any other power quality meter out there or any other software, it then shows you the event. What's really neat about this is once you pull that event up, you can then add additional quantities to it. So here we have three-phase voltage. There's a three-phase sag. We can go back into Sapphire and add additional values. So next slide, please. So if you go to add the new chart, it pulls up your chart selection again. So you can go in, and in this case, I want to add maybe, the waveforms, or I want to add something else to give a little bit more definition to what actually happened. Next slide, please. So I've decided here, I'm going to go ahead and type in the waveform so I can pull up and look at waveform data and see what the waveforms look like during this particular sag event. Next slide, please. And then once I press finished, it then populates waveform data associated with this tag. At this point, I can also add or take away time just with a couple of clicks of buttons. So I can add a second before the event, 2 seconds, a minute, an hour. So if there's something that's been cascading over, the past hour or building, I can, from this one event, add time to and from both ends and expand that out from a couple of cycles to well over an hour worth of continuous data. So that kind of gives you an example of how the power quality works as well. I think this is going to be the end of the presentation. Just in review, the meters and the software work together. You can build your power quality events in the software, so you don't ever have to worry about somebody setting a trigger wrong. You don't ever have to worry about missing the data in the field. As long as the meters are hooked up and installed and they're recording, once you get it back into the software, you can create your own trigger events to find the data you want to look for. You can, there's and, ors, there's nors, there's all sorts of gating logic you can use to create, to look for any type of events. So it kind of goes, you hook it up, you verify your hookup, you download it to the software, and then from there, it's just really finding what you're looking for and then sharing it.
Eric, you did a wonderful job, as always. I knew that you would do great, and thank you so much for spending some time with us today. Unfortunately, we're not going to have time for questions today, so I apologize. If we did not get to your question, we will send you an email here in the next 24 hours and address your question. But thank you so much for your participation, those who did ask questions. And Eric, once again, thank you so much.
Thank you all very much. Appreciate it.